Hello, this is Emmanuel, and in today's video, we'll be solving objectives questions on introduction and basic concepts of heat transfer. Please subscribe to my channel in order to get a notification whenever I upload a video like this. So let's go straight into it. So number one, the literature of heat transfer generally recognizes distinct mode of heat transfer. How many modes of heat transfer are there? So for this, the answer is 3. You have 3 modes of heat transfer. You have convection, you have conduction, and you have radiation. Number 2, convective heat transfer coefficient doesn't depend on, looking at the option is A, it doesn't depend on surface area. How many types of convection processes are there? So we have 3. We have the forced convection process, we have the free or natural convection process, and we have the mixed convection process. Then regarding one-dimensional heat transfer, choose the correct statement. So one-dimensional heat transfer, it means the answer is A, because in steady state the temperature is a function of direction, which is in this case is in the x direction, and in unsteady state the temperature is a function of both time and direction. So in one direction, which is the x direction, in also time, so it's a function of time in this one. So the answer is A. Which of the following is an example of steady state heat transfer? So for this one, the answer is D. Electric bulb cools down by the surrounding atmosphere. And heat transfer take place according to which law? So it's according to the second law, because it's the second law which talks about the movement of heat flow. So because of temperature difference, heat will be flowing from a hot temperature to a cold temperature. And number 7, the appropriate rate equation for convective heat transfer between a surface and adjacent fluid is prescribed by the Newton's law of cooling. During a cold winter season, a person prefers to sit near a fire. Which of the following modes of heat transfer provides him the maximum heat? So for this question, the answer will be D, radiation. Radiation will provide quick warmth. So in this case, radiation is the mode of heat transfer which will provide the person sitting under the fire the quick warmth. So number 9, the famous Fourier series is named after B, Joseph Fourier. Number 10, here are some assumptions that are made for Fourier's law. Identify the wrong one. So looking at these options, the wrong one, will be the C, the non-linear temperature profile. As if you watched my other video, the heat flow profile was a linear graph. So is the assumption made was that the heat flow was linear, not non-linear. Transmission of heat, molecular is smallest in the case of gases, because the molecules of gases are very apart, like they are wide, the space between them is wide, so transmission of heat is lower in this case. Thermal conductivity represents the amount of heat conducted across a unit area when the temperature difference of 1 Kelvin. This is false because of this statement, temperature difference of 1 Kelvin. Number 13, thermal conductivity is defined as the heat flow per unit time across a unit area where the temperature gradient is unity. So this is correct. Which one of the following forms of water have the highest value of thermal conductivity? This is a solid ice. This is because in a solid ice, the molecules or particles are closely, like they are compact. So transmission of energy or transfer of energy is being done easier. So looking at this option, solid ice will be the answer. And identify the very good insulator. So looking at this option, the very good insulator will be a glass wool. Heat conduction in gases is due to elastic impact of molecules. Yeah, so heat conduction in gases is due to the impact, like the collision of molecules in a gas. Then cork is a good insulator because it is porous. So cork is a type of insulator which is very porous, meaning there are holes in it. Consider the following parameters: composition, density, porosity, and structure. Then thermal conductivity of glass wool varies from sample to sample because of variation in all the properties. So there will be variation in all the properties. Yeah, there will be variation in all the properties. Let's go to number 19. The relation this is referred to as Laplace equation. Yeah. And number 20. In Cartesian coordinates, the heat conduction equation is given by A, this equation. In case of homogeneous plane wall, there is a linear temperature distribution given by, this one is given by D. The answer is D. A composite wall generally consists of multiple heterogeneous layers. So a composite wall might be a combination of different walls, and these walls may have different parameters such as density. 23. Consider system A at uniform temperature T and system B at another uniform temperature capital T. Then the temperature T is greater than the temperature capital T. Let the two systems be brought into contact and be thermally insulated from the surrounding, but not from each other. Energy will flow from system A to system B because of what? Temperature difference. Because the temperature, we have temperature difference. So temperature difference is the property in which, like, is the property for us to get in order for heat to transfer from one system to another system. The unit 24, the unit of the rate of heat transfer is what? We'll move to 25. The rate equation used to describe the mechanism of convection is called Newton's law of cooling. So the rate of heat flow by convection does not depend on time. Yeah. Thermal conductivity is maximum for which substance? Thermal conductivity is maximum for diamond. So if you look at the table, the one with the highest thermal conductivity is diamond. Yeah, because its molecules or structure or its lattice state is very compact. The molecules are very close to each other, so it provides a condition for thermal conductivity. 27. Which of the following is an example of forced convection? So the answer is B. Flow of water in condenser tube. Which statement is true regarding steady state condition? So in steady state condition, as in my previous video, in steady state condition, heat exchange is constant because there is no change in temperature. Heat transfer in a long hollow cylinder which is maintained at uniform but different temperatures on its inner and outer surface may be assumed to be taking place in which direction? This one, the answer is C, radial. So this will be the hollow cylinder. Then the temperatures at its layer, inwards layer and outwards layer, is different. So let's say the temperature here is higher, so it's moving to a lower temperature outside. So it will move like this, and this direction is moving in the radial direction. Number 30, heat transfer take place in liquid and gases is essentially due to convection. So convection is the heat transfer process which is taking place within liquid and gases. Yeah. So 31, identify the wrong statement. Third one, identify the wrong statement. So the process of heat transfer is an irreversible process, correct? For heat exchange, a temperature gradient must exist, correct? A material medium is not necessary for heat transmission. Yes, it's correct. Heat flow doesn't depend on temperature. This one is wrong because in order for heat to flow, for heat to be transferred, you should have a temperature difference. So it actually depends on temperature difference. Then number 32, most unsteady heat flow occurs during annealing of casting. Yeah, the answer is B. And Fourier's law of heat conduction is best represented by A. This is the formula for Fourier's law. Consider the following statement. The Fourier's heat conduction equation presumes steady state condition, constant value of thermal conductivity, uniform temperature at the wall surface, one-dimensional heat flow. So all these options are correct apart from the second option, this one. So the answer will be D. Negative sign in the Fourier's heat conduction equation indicates heat always flow in the direction of positive temperature gradients. No, this one. Heat always flows in the direction of negative temperature gradient. Yes, this is correct. So the answer is B. Which one is not the unit of thermal conductivity? So the answer will be C, looking at the options. So we move to number 37. Which of the following is a unit of thermal resistance? Is degree over watt. And number 38. Mark the matter with least value of thermal conductivity. So this one is air. So air is, looking at the options, air is the matter with the less conductivity. The average thermal conductivities of water and air conform to the ratio 25:1. Yeah. Most metals are good conductors of heat because of the free electrons and frequent collision of atoms. The heat energy propagation due to conduction heat transfer will be minimum for air. The heat energy propagation due to thermal heat transfer will be minimum for air because it has the less thermal conductivity. Choose the false statement. In this question, they are telling us to choose the false statement. So A is, for pure metal, thermal conductivity is small. Yeah, it's true. Thermal conductivity decreases with increase in the density of the substance. Yeah, there is the correct answer. So this answer will automatically be wrong. Then 33. The thermal conductivity and the electrical conductivity of a metal at absolute temperature are related as this. So related as K divided by this. Okay. So we move to 44. The unit of thermal diffusivity is C, meter square over R. The diffusion equation, this governs the temperature distribution under unsteady heat flow through a homogeneous and isotropic material. The Fourier's equation from the expression when temperature doesn't depend on time, when there is no internal heat generation, steady state condition prevails. There is no internal heat generation, but unsteady state condition prevail. So the answer over here is the D. Yeah. And 46, the temperature distribution in a large thin plate with uniform surface temperature will be assumed steady state condition, will be linear. Heat is transferred from a hot fluid to a cold one through a plane wall of thickness, this surface area, and thermal conductivity, this. The thermal resistance is, looking at the options, the thermal resistance will be that of the A. Thank you very much for watching this video. So in the next video, we'll be solving problem type questions of heat transfer.